Now in the second part, we know that in the level 1 we covered these 3 steps of, or these 3 methods of beam design. The first one is the general design chart method, second one is the KD method where we dealt with tables, and the third one will be using formulas. Okay, now in this course we will focus on this single method of calculation for the beam, for the revision. Okay, now when we are dealing with the general design chart method, we have this chart. This chart is given in the design aid for the Ethiopian Code 1992 on page 15, and this is called the general design chart method. So here you need to calculate some factors, and based on that factors you will determine another parameters, then you are going to calculate the reinforcement. As a result, the main steps for the design of beams for flexure basically will be the material part. Okay, the material part. So in this material we said that we have 2 materials, that's the concrete and the reinforcement. Okay, so as an engineer, as a designer, you will first start with assuming or deciding the material, the concrete, for example, maybe C25 by 20 by 30, I mean, or C20 by 25 or whatever. Okay, considering the available materials and the recommendations. Okay, the recommendations. And for the steel, you may start with steel reinforcement with characteristic yield strength of maybe 400. Okay, you may start with this one, which here we call it maybe S400, or with characteristic strength of yield strength of 460, because the code specifies from 400 to 600. Okay, the material available in the market must be taken into consideration. Once you decide this, you will determine these related parameters. Okay, that's FECD, FECK, and so on. Okay, for the concrete, and for the reinforcement, the design yield strength, and maybe if you need to determine the Young's modulus of elasticity. Okay, this. Now once you decide with this one, you are done with the material part, and you will go to the geometric part. This here you will determine the effective depth, the total depth, and maybe the clear cover, the width, and the rebar diameters will be decided here. Once you decide here, you will continue with the third step, that is the determination of relative moment capacity. Once you decide this, you go to the table, to the chart, and from the chart you will read a parameter that's called KZ, and after that you will calculate easily the area of steel required. Then from this you will determine the number of the bars, and finally you will provide detailing. Detailing will include the longitudinal profile of the beam, the sectional profile, and rebar cutting, lapping, overlapping, bending, and other relatives. Okay, however, before doing all these, there is one critical step that you have to do, or you have to perform. That is the analysis part. Okay, these are the design part. In the analysis part, you need to determine the loads on the beam, the bending moment diagram, the shear force diagram, and the torsional diagram if there is a torsion. Okay, we will deal with this one in the third chapter. Okay, however, we will deal with these 2 parts in this chapter. Okay, now the proper analysis of the member is really crucial. If this is properly done, these other are just a piece of cake. Okay, it will be very easy. Now some important issue that you should not forget is when you are determining the loads on the beam, do not forget to consider the self weight of the beam, because when you increase the depth, the self weight of the beam also increase. So you have to, again, if for example if you revise the section, you have to return it back and analyze and determine the loads on the beam, then and again keep repeating the calculation for the bending moment and the shear force. Okay, this much introduction is enough. Saying this, let me directly go to the example.